Hello and welcome to Uni What? Today we will complete the chapter, The Human Eye and the Colorful World. Let's finish it. Refraction of light through a prism. The angle between the incident ray and the emergent ray is called the angle of deviation. According to Snell's law, light traveling from a rarer medium to a denser medium will bend in the opposite direction of the normal. Because glass is denser than air, when light strikes the prism surface, it bends toward the normal. The diagram shows that ray PE hits the prism surface and bends in the direction of the normal NE. The emergent ray FS then bends away from the normal as it transitions from the glass to the air. A measure of how much the emergent ray has diverged from the incident ray is the angle of deviation or angle HDS. The deviation angle is minimal when the angle of incidence and angle of emergence are equal. The angle of minimum deviation is thus angle HDS, and the diagram shows that angle PEnd equals angle MES. In this instance, the refracted ray EF is parallel to side BC. What is dispersion? When white light is passed through a prism, it splits up the light into 7 colors. The splitting up of white light into its component colors is called dispersion. The deviation of red is the minimum and violet is the maximum. What is a spectrum? The band of colors obtained on a screen on passing white light through a prism is called the spectrum. Causes. The refractive index of glass for different colors is different. The refractive index is largest for violet and least for red color. It occurs because the speed of light of different colors in glass is different. Sunlight is made up of 7 colors, Newton. 2 prisms, one upside down will recombine the colors to give a white light if white light falls on the first prism. Rainbow and what causes them. A rainbow is a natural spectrum appearing in the sky after rain. It is caused by the dispersion of sunlight by tiny water droplets, present in the atmosphere. The water droplets act like small prisms. They refract and disperse the incident sunlight, then reflect it internally, and finally refract it again when it comes out of the raindrop. A rainbow is always formed in a direction opposite to that of the sun. What is atmospheric refraction? A ray of light from an astronomical object has to travel through different layers of the Earth's atmosphere. These different layers have different densities and different refractive indices. The refraction of light caused by the Earth's atmosphere, which has different densities, is called atmospheric refraction. Why do stars twinkle? The twinkling of a star is due to the atmospheric refraction of starlight. Because of the larger distance, the stars appear to be point objects with respect to an observer on the Earth. Due to changes in atmospheric conditions, the path of the rays of light varies slightly, the apparent position of the star fluctuates, and the amount of starlight entering the eye increases and decreases continuously. Thus, stars appear twinkling. Why don't planets twinkle? The planets are closer to the Earth than the stars. Therefore, they act like extended objects. An extended object has a number of point objects in it. The light rays from all these point objects cancel the effect of atmospheric refraction on each other. Therefore, planets do not twinkle. Why is a star observed higher than its actual position? This is due to atmospheric refraction. Due to changes in atmospheric conditions, when sunlight enters the atmosphere, it bends towards the normal. Hence, the apparent position of the star is slightly higher than its actual position. Why does the sun appear in the sky 2 minutes before actual sunrise? It is because of atmospheric refraction. When the sun is slightly below the horizon, due to changes in atmospheric conditions, light rays bend towards the normal. Hence, the apparent position of the sun is slightly higher than its actual position. Therefore, it can be seen 2 minutes before actual sunrise and 2 minutes after actual sunset. The apparent flattening of the sun's disk at sunrise and sunset is also due to atmospheric refraction. Scattering of light. When a beam of light strikes minute particles, the different colors of white light get separated and travel around the particle in different directions. The color of the scattered light depends on the size of the particle. A. Very fine particles scatter mainly blue color. B. Large-sized particles scatter red color, which has a longer wavelength. C. Enough larger particles scatter the light which may appear white. Why is the color of the sky blue? This is due to the scattering of light. When sunlight passes through the atmosphere, the fine particles in the air scatter the blue color, which has a shorter wavelength, more strongly than red. Why does the sky appear dark to astronauts? There is no atmosphere containing air in outer space to scatter sunlight. Therefore, the sky looks dark. i.e., no scattered light reaches our eyes. Why the sun looks almost reddish at sunset or sunrise. At the time of sunset or sunrise, the sun's rays have to travel a larger distance. Most of the blue light of a shorter wavelength is removed by scattering. Why does the sun appear white at noon? During noon, the sun is overhead. Sunlight travels less distance through the atmosphere to reach our eyes. In this case, the scattering of almost all the colors is nil. Why are clouds white? Clouds are made of water droplets of different sizes. These different sized droplets scatter different colors. As a result, the resultant color will be white. Why are danger signals red? The wavelength of red color is longer and it is least scattered while passing through the atmosphere, therefore, it can travel long distances. What is the Tyndall effect? The phenomenon of scattering of light by colloidal particles is known as the Tyndall effect. This effect can be observed when A. A fine beam of sunlight enters a room containing suspended particles of dust. The path of the beam of light is visible. It is due to the scattering of light. B. Sunlight passes through a canopy of dense forest. The path of the beam of light is visible. It's that easy, guys. Hopefully you had fun learning this chapter. And don't forget to subscribe. It's faster than your teacher's catching skills.